Yo, 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 Coach Ray back here with another Piecewise video. We're actually starting the second lesson, even though we're breaking Piecewise up into a bunch of videos. This is the beginning of the second Piecewise lesson. This lesson is titled Graphing Piecewise. Okay, the first lesson was Evaluating Piecewise. All right, so now, with all graphing lessons, you just need to know you're going to have a laptop with Desmo sitting next to you during your test. So with all graphing lessons, as long as you know how to plug it into the laptop, it'll show up in front of you, and then you just have to transcribe that onto your test. But still, we already talked about plugging Piecewise into Desmos is kind of complicated. So this might be one where it's better to do by hand using your brain. And even if not, I think there's still value in you seeing how to do one of these by hand, because I think you'll understand Piecewise functions better. Okay? So here's what I'm looking at. I'm looking at, in example 1, I'm looking at a Piecewise function. How many pieces are there? 3. There are 3 pieces. Okay, we can see the 3 pieces. And most of the examples we've done so far have had 3 pieces. That is not always the case. We can have 2, we can have 4, you can have as many as you want. Most Piecewise functions are between like 2 and 4 though. Okay? Over here on the right side, here are my boundaries. And that's where I'm going to start on this graph. I'm going to break this graph up into my 3 pieces. Okay? And these boundaries tell me how to break it up. So the first boundary is telling me, okay, to the left of -3 is where this one goes. In between -3 and 2 is where the middle one goes. To the right of 2 is where this one goes. So that's where my 2 boundaries are. One of them is at -3, one of them is at +2. All right, so I'm going to use a highlighter. So I'll try to make it look nice, but I'm going to use a highlighter, and I'm going to start at x is -3, and I'm just going to put a boundary mark all the way down here at x is -3. All right, my other boundary is a +2, so I'm going to use my same highlighter, and I'm going to just try to go straight down here and put a boundary at +2. So now you can see the 3 parts of my graph, and just kind of to make sure we're clear, this top equation goes left of -3, so that'll just be in this left section. This middle one goes in between -3 and 2, so it's going to go just in this middle section. And this bottom one, -2x + 6, will just be graphed to the right of 2, so that'll just be in that right section. So when I break these up using these boundaries, now you can kind of see what's going to go where. All right? I'm going to start with the middle function. And that's because I think the middle function is usually the easiest one to graph. Okay, so I'm going to start with the easiest one. So what I'm going to do is I'm going to graph this line, y = x - 2, and I'm just going to graph it in this middle section. Okay? So let's see. I know that my y-intercept in this equation is -2. So I'm going to put my y-intercept right down here on the y-axis at -2. I'm going to look at my slope to this line, y = x - 2. My slope is 1. Okay, 1 over 1 in fact. So my rise is 1, my run is 1. So from my y-intercept, I'm rising 1, running 1, putting a point there. I'm rising 1, running 1 again, putting my point there. And I'm not going to keep going, right? Because this line does not get graphed to the right of that boundary. It only gets graphed in the middle, so I'm just going to stop right there. All right? I also want points coming over to the left here so I can see this whole way. So if I'm going up 1, right 1, I'm going to do the opposite going the other way. Down 1, left 1, I get a point here. Down 1, left 1, I get a point here. Down 1, left 1, I get a point here. I'm going to put as many points as I can in there just to show exactly where my line's going to go. And I'm going to draw my line in now. Okay, so what I've done now is I've graphed y = x - 2 just inside this boundary of, where's my mouse? Oh, I lost my mouse. There it is. Just inside this boundary of -3 and +2, so just in the middle here. Okay, that's the easiest one. Next easiest one to graph is usually the one to the right. So I'm going to come down here to this bottom one and do this -2x + 6 problem. And it tells me that I'm only graphing this to the right of 2. And this is where it gets complicated, so make sure you're super focused right here. My y-intercept is 6. Okay? So that means on my y-axis, I should start at 1, 2, 3, 4, 5, 6. This is where I should start. But the problem is this line is not going to be graphed in this middle section. Okay? The most common mistake that people make during Piecewise is they go up their boundary and go 1, 2, 3, 4, 5, 6, and they start right here. That's not a y-intercept. That's like a boundary intercept or something. Okay? So you still need to start over here on the y-axis, but I just kind of use my finger and don't draw it in until I get to my section. Does that make sense? So I know that I'm starting here, 1, 2, 3, 4, 5, 6. I'm starting right here, okay? And my slope is -2, which means rise -2, run +1. So from here, I'm going down 2, I'm running 1. I'm still not putting my point right there because it's in the wrong section still. So I'm going to do my slope again. Rise down 2, run 1. And that is going to be where my first point goes. Okay, my first point is going to go right here. Because now I'm going to start seeing where my line is supposed to be. And now I can keep my slope going. So from here, rise down 2, run 1. Okay, and then I'll just keep it going. Rise down 2, run 1. Down 2, 1. And I'm just going to fit a bunch of points till I get to like the end. And I'm going to get my line in there. Okay, kind of ugly. Let me redo that. Whoa, super ugly. I should spend the whole video trying to make this line perfect. Okay, close enough. All right, so I've got my middle one graphed. I've got the one to the right graphed. Usually the one going to the left is the hardest because you've really got to go backwards. All right, so I'm going to try to show you that here. So this top one is the only one I have left. I graphed this line to the left of -3 because it says x is less than -3, so that's going to be over here. All right. I start with my y-intercept. My y-intercept is +2, so in here I start at +2. But the thing that sucks here is as I do my slope, it gets kind of messed up. -2/3 would mean rise down 2, run 3. But I'm heading the wrong direction. I'm not even going towards my stuff. Okay, so from here, if I'm supposed to go down 2, right 3, I'm just going to do the opposite. From here, I'm going to go up to left 3. And since that hits my boundary, that's going to be my first point for this top section. And then from there, I can go up to over 3 again, up to over 3 again, and just get a couple on there to fill up the graph. All right, so I'm almost done. The only thing I have left is to determine, for example, when x is -3, everybody watch closely. This is the biggest question I get all the time. The question you're going to ask me later is going to sound like this. Coach Ray, in piecewise, what's up with the filled in dots and the open dots? That's what I'm going to try to really explain right now. Okay, so if I asked you to evaluate f of -3, which was one of our other videos, I'd be asking you, where is our function at -3? Could be up here with the green one, could be down here with the red one. How we tell is by looking over here at our boundaries. Okay, if I said evaluate f of -3, -3 is not less than -3, so you would not use the top one, which is the green one. Okay, you would use this middle one because -3 is greater than or equal to -3. Really what you're looking for is the equal to sign for the filled in dots. You're looking when it doesn't have the equal to sign underneath, that's an open dot. So this top guy right here, we're not putting -3 in up here. So how we show that is with a very clear open dot right there. And to show that the filled in dot belongs to the red one in the middle, we're going to do a very clear filled in dot down here for the red one. That shows whoever's looking at my graph that if you need to know where to go at -3 for x, it's very clear you go down to the red one, not up to the green one. Okay? Same with the red versus the blue. This red versus blue is talking about 2. So when x is 2, do I come down here to the red one or to the blue one? I'm going to look over here. The blue one has the equal sign, so the blue one is going to get the filled in dot. That belongs right here. Okay, and to show that it's not the other one, I'm going to make a very clear open dot to show that it does not belong right there. Okay, we will do example 2 on another video. That is it for this one. Thank you for tuning in and subscribing and